are related to exponents. In grade 9, you started learning exponent laws. Remember your exponent laws for grade 9? Right? Exponent laws in grade 9, sometimes, if you brought a grade 5 kid in to watch grade 9 students, they would think, oh my goodness, high school math, they've lost it. Because you learn some crazy stuff, like, and math teachers are bad for this. What's the exponent law there? When you multiply, what do you, okay, you add the exponents, right? And often you'll hear in a math class in grade 9, we take out words sometimes when we teach math. We'd be like, okay guys, we're multiplying, what should we do? And the kids go, we add. And the grade 5 could be like, multiply, you add? What? I thought multiplying was multiplying. When you divide, what are you supposed to do with exponent laws?
Minus.
Yeah. The kid's like, what? Divide is now minus? Have they gone crazy in high school? But those are our exponent laws. We should say, when you multiply two powers with the same base, you can add the exponents. Oh, that's a mouthful.
Add in some letters and stuff.
Right? So instead you just say, when we multiply, we add. Well, for every exponent law, now that we're getting into logarithms, there's a log law. Log law. So the first log law is connected to this one. When you multiply, you add with exponents. When you multiply powers with the same base, you add the exponents. When you multiply inside of a logarithm, it is like adding two logarithms with the same base. So if I have log b of x plus log b of y, I am adding with the same base, so I can combine it as multiplying inside. If we go back to the one that I said, hey, this is interesting. Check this out. I'm adding with the same base. So that means I could combine these with the same base and multiply. What is 4 times 16? It's 64. What exponent would I get? 8 to what exponent is 64?
2.
2. This makes sense. Without having to, like, we figured out this was 2/3. You could have figured out that this was 4/3. And 2/3 plus 4/3 would give you 6/3, which is 2. That would be a much longer way, but now that we see that there's a log law that says if you are adding two logarithms with the same base, you can combine those to a single logarithm with that same base by multiplying inside. So when you add, you multiply is still true with logarithms. When you divide, you subtract. When you divide two, right, if I have two powers with the same base and I divide, I can just subtract the exponents. Yes.
This might, yeah. Why don't they teach logs at the same time as exponents? Like,
Well, once we get into this unit, you'll probably understand why your grade 9 brain was not quite ready for that.
But like, with just like rearranging a log. To make
It's not super hard, but just the word, I don't know, there's some stuff in it that, but the basic part could be happen, right? Quotient law says if you are subtracting two logs with the same base, you could combine them and divide inside the logarithm. And the power law in exponents saying if you have a power to another exponent, what did we do to those exponents? We multiply the exponents together. In logarithms, if you have an exponent inside the logarithm, it's like you can move that exponent out in front and multiply instead. In our log laws like identities, this side is considered the simplified side. a single logarithm is considered simplified. This side is the expanded side. We get really good at our logarithm laws so that we can apply it and actually start solving questions like what could x be? Right now, the only way you could do this is if you type the one side into y1 in Desmos or a graphing calculator and type the other into y2 and hope they intersect and find out where that intersection is. But you would need a graphing calculator to do that. Do you get a graphing calculator on the exam? No. Will you be asked this question on the exam? Something similar? Yes, absolutely. And you'll have to know your logarithm laws in order to solve it. But before we get there, we have to get good at our logarithm laws. Which means sometimes you'll get the simplified form and they say, can you expand it? And sometimes they give you the expanded form and can you simplify it? And working from left to right with these formulas is really important. Moving on. These are the only formulas. Well, we have one more, but we're not there yet. These are your only log laws. If you make up anything else with logarithms, it's going to be bad. You're fucked. Right? There is no log law for adding. So a student has this, hey, I have log x plus y. I'm just going to write log x plus log y. That makes sense to me. Can I just distribute? No. Absolutely not. This is bad. Catastrophic mistake. Catastrophic mistake means I stop marking. If you make the catastrophic mistake in step 1 of a 4-mark question, you're done. Doesn't matter what you do after that. So, we don't want to make up log laws. These are the ones that we have. And they have to match up perfectly to work. So, example 1. Example 1 has simplify. Simplify is the left-hand side of a logarithm. Sometimes you will see the same instruction the left-hand side all has single logarithms. So sometimes instead of the word simplify, you will see combine as a single logarithm. Use a calculator to verify each answer. That means type this into your calculator, see what you get. Type your simplified one into a calculator. If they're the same, you know you've done it right. So in A, I have a log law that says if I'm adding 2 logs and the bases are the same, are the bases the same in A? Right? If they're not written, what is the base that's hidden?
10.
A 10. That's your common log. So the bases are the same. I can combine this as a single logarithm, keeping the same base of 10 and multiplying. 7 times 8, which I can simplify that to 56. Are these the same? We'll take out our calculator and check log 7 plus log 8, enter, and log of 56. Perfect. They are identical. This means 10 to the exponent of 1.7481888027 happens to be 56. Which you can now do some crazy mental math. Okay, I'm going to get you to do some crazy mental math in your head. Do not give up. Okay? Don't worry, I won't require, you should be fine with only 12 decimal places in your head. Okay? First of all, I want you to quickly calculate log of 2 to 12 decimal places, please. Then, that shouldn't take too long. I'd like you to add Log of 50. So get log of 50 also to about 12 decimal places. Take your answer from log of 2, add it to your answer of log of 50. And what do you get? 2. Perfect. That is an impressive like 12 decimal places. Right? That's impressive. What did he do? He cheated. You see how he cheated?
Yeah.
Yeah. You got the log law. Adding means that you could multiply inside, and 2 times 50, 100, 12 decimal places, 100 points. And then the base is 10. 10 to what exponent is 100? It's 2. Okay, so sometimes even though we can't do the individual ones, we could do them together, which is super cool. Okay, B. This is not simplified because there's a 5 out in front. Logs are simplified when there's a single logarithm. What can I do with that 5? I have a log law that says if I'm multiplying a log by something, I can move that in as an exponent. So that 5 moves in as an exponent, 2 to the 5. It's on our powers chart, that's 32. There's our answer, and we can double check with our calculator. Is 5 log 2 the same as log of 32? It is. 10 to the 1.50511149978 happens to be 32. And finally, I'm dividing. Oh no, I'm subtracting. I got ahead of myself. I'm subtracting 2 logs. I have a log law that says if you subtract 2 logs, that's the same as keeping the base the same, and notice these all have the same base. Base is 10. 80 divided by 60, which would be log of 5. So if I get a single logarithm, that is considered simplified. Questions to circle, for example of 1. Example 1 are 4 and 12.